So we're now into our second to last main topic of this course, which is inverse trig functions and their graphs. And really the graphs are a lot less important than the actual functions themselves because this is what we're going to need to solve trig equations. So we're going to look at the inverse sine function, the inverse cosine function, and the inverse tangent function. I crossed off the inverse secant, cosecant, and cotangent functions because those aren't really going to be super important for us. So the first thing is just recalling what it means to be an inverse function, right? Remember we use this notation for inverse function? We would read that f inverse. So what it does is it just reverses the rule of f. And if you remember when we did inverses, we had to make sure that a function was 1-to-1 for it to have an inverse. Now, could we get around that some ways? Of course. Like when we took the graph of y equals x squared, what did we do? We knew that y equals x squared was a parabola, so that clearly didn't pass the horizontal line test. It wasn't 1-to-1. So what we would do is, rather than use the whole graph, we would only take one side of it, and then it would, of course, pass the horizontal line test, and it would have an inverse, right? So the inverse of y equals x squared when x was greater than or equal to 0 was y equals the square root of x. So then it would have an inverse. We would cross off the left-hand side. Okay, so what we're going to have to do is something similar with the trig functions because clearly they're periodic, so they keep repeating themselves over and over again. Therefore, they're not 1-to-1. So we're going to have to do what we call restricting the domains. So the first thing we're going to do is the inverse sine function. So we know that the general sine graph, right, looks like that if this is 0 and that's 2 pi. And then if we went to the left, it would look like this. And what you want to do is you want to realize, hey, if I look from here to here, on that interval there, which is the interval from negative pi over 2 to pi over 2, it actually does pass the horizontal line test, right? That would be a 1-to-1 function if we just restrict the domain to be between negative pi over 2 and positive pi over 2. So that's what we're going to use as our domain for the restricted sine function. Now you can make the argument, well, why don't you use this over here from pi over 2 down to 3 pi over 2? We could, but generally you want to try to include 0 if you can. You want to get basically as close to 0 as you can. So if you do this straddling interval from negative pi over 2 to pi over 2, which straddles 0, that's actually the best interval to use for the restricted sine function. Okay, and then they just give you a little, a better picture of it than I gave you, right? They show you the sine curve and how they're limiting the domain to be between negative pi over 2 and positive pi over 2. And then there's your function. So if you remember, what ends up happening is with the domain and range, so if we had this original function y equals sine x, we'll call it f of x, I guess, right? We'll call it f of x equals sine x, where negative pi over 2 is less than or equal to x, which is less than or equal to pi over 2. The f inverse, which we're going to call inverse sine of x, that's going to have a domain of negative 1-to-1, but it's going to have a range of whatever the domain of the original function was, right? So the original function had a domain of negative pi over 2 to positive pi over 2. So this inverse function is going to have a range of negative pi over 2 to positive pi over 2. And this is super, 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 super important to remember for when we do the evaluating of the inverse sine function, right? We have to realize that any value we get back is going to always fall between negative pi over 2 and positive pi over 2. So again, that's super important. So again, this was just the idea of switching the domain and range. So the domain of the restricted sine function becomes the range of the inverse sine function. And the range of the original sine function, which was negative 1 to positive 1, becomes the domain of the inverse sine function. Okay, the domain and range just switch. So that was really nothing new. That was just what it meant to be a inverse function. So there it is right there. So what they're telling you here is what I just stated, that the domain of that inverse sine function is negative 1-to-1, and the range is negative pi over 2 to positive pi over 2. And then they just give you this equivalence relationship. So y equals inverse sine of x is equivalent to sine of y equals x. And another thing that you'll often see is instead of writing this notation, the inverse sine notation with that little negative 1 kind of like as an exponent, you'll sometimes see it written as arcsine. So these two things, those two notations, those are going to be interchangeable. So what this is telling you is this is just telling you that these two statements mean the same thing, right? Inverse sine of x equals y basically means the same thing as the sine of y equals x. And then what they tell you down on the bottom there is very important. Inverse sine of x is the number between negative pi over 2 and pi over 2 whose sine is x. So when you're asked to evaluate an inverse sine, you're looking for they're calling it a number, but it's probably easier to think of it as an angle, right? So the inverse sine of x is the angle whose sine is x, right? The angle between negative pi over 2 and positive pi over 2 whose sine is x. All right, so that's probably like a more layman's term way of saying it. Inverse sine of x is the angle between negative pi over 2 and pi over 2 whose sine is x. That's a nice way of thinking about it. And then they just give you the inverse properties, right? So if you take the sine of the inverse sine of x, you get back x, right? As long as x was between -1 and +1. And if you take the inverse sine of the sine of x, you get back x. But this is super important. This is what I was talking about before. As long as x is between negative pi over 2 and positive pi over 2. If x is not in that interval, this is not going to be true, right? So this is super, super important to note. And I'm just reiterating what it says. Only true for x in negative pi over 2 to positive pi over 2. And we'll look at a couple of those in a second that won't actually work because x will not be in that interval. Okay, so like right here, what's the inverse sine of the sine of pi over 3? Well, the nice thing is that pi over 3 is in this interval. That symbol that I'm using there, which I wrote poorly there, it just means is an element of. So we can think of it as is in, right? So pi over 3 is in this interval here. All right, it's part of this interval. So since pi over 3 is part of this interval, this is just going to be your inverse property where you're going to get your cancellation. The inverse sine and the sine basically cancel, and you just get pi over 3. Okay. Now with this one, however, 2 pi over 3 is not in this interval from negative pi over 2 to positive pi over 2. And because of that, this thing is not going to equal 2 pi over 3. Okay, so what we're going to have to do is we're basically going to have to just take it in steps. So we're going to have to evaluate the sine of 2 pi over 3. Okay, so the sine of 2 pi over 3 is square root of 3 over 2. Now, how do we know this? Because the reference angle, which we had called, what did we call the reference angle? T bar. T bar is pi over 3, and the sine of pi over 3 was square root of 3 over 2. So that's why they got square root of 3 over 2 here. And now when we take the inverse sine of radical 3 over 2, we need the angle between negative pi over 2 and positive pi over 2, whose sine is square root of 3 over 2. Which angle between negative pi over 2 and positive pi over 2 has the sine of radical 3 over 2? It's actually what we just did there, right? Pi over 3, right? It's actually this reference angle, t bar. So we end up getting pi over 3. All right. These are going to take a little bit of getting used to. Okay, because what your original thought there is to just say, oh, those cancel out, so I just get 2 pi over 3 back. The problem with that is 2 pi over 3 is not in the interval from negative pi over 2 to positive pi over 2. So again, these take a lot of getting used to. And then I just included some more examples here. So what's the inverse sine of 1? So in other words, which angle between negative pi over 2 and positive pi over 2 has a sine of 1. So what you want to do when you really are evaluating all these inverse sine problems, you want to think about the portion of the sine graph that you're using. So bottom line is, which angle between negative pi over 2 and positive pi over 2 has a sine of 1? Well, here's where the sine is 1. And what angle is it? It's right here. So it's pi over 2. So for this other one, which angle between negative pi over 2 and positive pi over 2 has a sine of -1? Well, here's where the sine is -1, and this angle here is negative pi over 2. Now, the mistake that a lot of people make with this is they say it's 3 pi over 2, right? And 3 pi over 2 isn't a bad guess, but that would be if we included this as our restricted sine function, right? And we're not including that as our restricted sine function. We're including the interval from negative pi over 2 to positive pi over 2 as our restricted sine function. So we don't say 3 pi over 2, we say negative pi over 2. All right, so this one is asking you which angle has a sine of 0. Well, here's my interval that I'm looking at. Well, when is the sine 0? Right here. at 0. Now this one is where you get tricky. Which angle has a sine of negative a half? Well, I know it's going to be over here somewhere, right? Because this is where my sine is negative, over here between negative pi over 2 and 0. So what you're doing is you're looking for the reference angle that has a sine of positive 1/2. So in this case, the reference angle is actually pi over 6. Pi over 6 is your reference angle, but what is pi over 6? If I'm thinking in the fourth quadrant but a negative, it actually becomes negative pi over 6. So then the sine of negative pi over 6 is actually negative a half. And that's the way that you could check these, honestly, right? You could say, all right, well, I know that then when I take the sine of negative pi over 6, I should get negative a half, right? So what's the sine of negative pi over 6? It's negative 0.5 or negative a half. All right, so that's kind of a way to check yourself after you do these. And now over here, which angle has a sine of radical 2 over 2? Well, over here now I'm in this positive area, right? So where is the sine radical 2 over 2? Well, the reference angle here was pi over 4. And in this case, since I'm between 0 and pi over 2, my reference angle actually is my value, right? So it's inverse sine of square root of 2 over 2. That's actually pi over 4. Now here is where you get a little bit weird, because which angle has a sine of square root of 3? Well, the square root of 3 is like 1.7 something. Does the sine graph ever get above 1? No. So this thing is undefined, because square root of 3 is not in the domain of this inverse sine function, right? The domain of the inverse sine function is only between negative 1 and positive 1. And then this one, inverse sine of negative 2/3. Well, this one we don't have we don't know what the reference angle is for it. So this one we would basically just punch in our calculator, and we have to get an approximation, because this is not one of our trig wheel values, right? So what we would do is we would do inverse sine. And how do you do inverse sine? You do second sine. So that's your inverse sine of negative 2 over 3. And that's going to be negative 0.7297 if we go to 4 decimal places. So this is approximately negative 0.7297. So that one we just have to approximate. And then this one, inverse sine of negative square root of 3 over 2. Well, we know the reference angle here, right? Which angle has a sine of square root of 3 over 2? The reference angle, that's actually going to be pi over 3. But since we're looking over here in this interval between negative pi over 2 to 0, which angle between negative pi over 2 and 0 would have a reference angle of pi over 3? It's actually negative pi over 3. The important thing to remember here is that inverse functions, inverse trig functions, are functions. So you can only get back one value. What a lot of times people will do here with a problem like, let's say this one, inverse sine of square root of 2 over 2, they'll say, oh, well, there's two angles actually that have a sine of radical 2 over 2. It's pi over 4 and 3 pi over 4. And yes, you will have to do this when we solve equations. You'll have to think of all possible solutions. But this is a function. We're not solving an equation here. We're actually evaluating a function. So there can only be one value. So we would reject the 3 pi over 4, because 3 pi over 4 is not between negative pi over 2 and positive pi over 2. And then the same thing here. Like you might say, all right, not only does negative pi over 6 have a sine of negative a half, but also the angle in the third quadrant, 7 pi over 6, also has a sine of negative 1/2, right? If I punch that in the calculator, what's the sine of 7 pi over 6? All right, that's also negative a half. The problem is, once again, we would reject this one because inverse sine is a function and we can only get one value for it. So 7 pi over 6 is not the value that we want. It's actually negative pi over 6, because the value has to be between negative pi over 2 and positive pi over 2. So again, this is the kind of thing that takes some getting used to. You have to do a lot of practice with these and realize, all right, well, whenever you're doing inverse sine, you're always going to end up with a value between negative pi over 2 and positive pi over 2.